Hello, everybody. Welcome. My name is Madeline, and I am the Energy Storage Manager. Thanks, everybody, for being here. We're really excited to be talking with Outback. We're going to be discussing the SystemEdge Sizing Tool, which is a great newly launched web-based tool to help everybody with sizing their energy storage systems. So without further ado, I'd love to introduce Mark Mays, who's the Senior Applications Engineer, and he can give us all the information that we're going to be needing about this new great design tool. So take it away, Mark.
Okay, thanks, Madeline. And thank you very much for hosting this event for us. And welcome everyone else. Good morning or afternoon, whatever the case may be in your location. I'm broadcasting from Bellingham, Washington, a city up close to the border to Canada. This is our one of our corporate headquarters here. And so, yeah, a little bit about myself. I'm an applications engineer with Outback Power. Prior to coming with Outback Power, I had some pretty extensive background in troubleshooting power quality problems, doing power quality audits, and I worked for a company called Fluke for a number of years. I helped develop some of the specifications on our power quality equipment and whatnot. So I had a pretty good background in power distribution before I came here to Outback. And also variable frequency drives was another application area for me. And had, they have inverters and converters in them. So I thought, oh, well, I come work for Outback. This should be kind of a breeze learning the system. And I realized that there's a little bit more to it than I thought because when you size the batteries to the loads and then you size the solar to keep the batteries charged, and then you have to size the inverter for maximum amount and surging, and then you have throw in the customer loads, site loads. So between those 5 different components of the system, there's a heck of a lot of interaction going on there. And over the course of troubleshooting a lot of systems, getting call escalations from tech support, I began to realize that 90% of the calls that we got, troubleshooting calls, post-sales, fell into one of 3 categories. So it was either a design issue, a configuration issue, or a sizing issue. Seriously, 90% of the problems fell into one of those 3 areas. And yeah, occasionally we do get some product failure, no doubt. So electronics fail at times. So that's when we started coming up with some sizing tools. And we all kind of had our own little tool that we used, and then we kind of developed one amongst us apps engineers. But some of our sales guys said, that's a little bit, complex and this and that. It was kind of spreadsheet based. And so then we came out with our SystemEdge packages, which are complete energy storage systems. So it's the batteries integrated with the PV and the inverter and, everything together, except for the solar panels themselves. So we decided, we should come up with a sizing tool to eliminate that 90% of the problems that people run into. So this is the culmination of a lot of hours of design and development, and we wanted to make the user interface fairly simple and intuitive, and have it a web-based tool and all that. So it's really been quite an effort we put into making this happen. But before we get into the tool itself, I just want to do a little bit of a background information on the SystemEdge themselves, so you know what this is designed for. This is kind of our turnkey energy storage system, if you will, is SystemEdge. Okay, so there is a standard for energy storage systems, UL 9540. And what it is an energy storage equipment certified as a system, and is comprised of a UL 1973 certified stationary battery pack and a UL 1741 certified inverter. So these two pieces that have been, tested, thermal, electrical, ensure that there's going to be a nice integration of a high performance system. These two certified together make up a UL 9540 energy storage system. And that is, you can see this UL listing mark here, as well as here on our integrated battery rack. And you notice this little LI at the end for lithium. So UL 9540 only applies to systems with lithium batteries, okay? So that does not mean that you can't use like lead acid AGM batteries. It's just that where this UL 9540 is required, it only applies to lithium batteries. So if you live in California, maybe we can do I'm going to just do a quick, see if I can do the show of hands thing. So I think on your participant screen, you can do a show of hands. How many people are in California? So I don't know if you can find your raise your hand thing. Okay, I'm seeing the hands go up. So
I saw 7 hands raised.
7 hands. Yeah, they're all seem to be at the beginning here. Yeah, so there are some of you that are in California that are participating here. So one of the things, though, about even if you're not in California, and if you are in California, just let me cover that case first. The 2018 California Building Code, they've adopted the IRC's International Residential Code that requires UL 98540 for energy storage systems. But again, that only applies to lithium-ion based batteries. Now, it's my understanding from talking to some of our regulatory experts here at OutBack that they are going to come out with a UL 9540 like -2 or B or whatever it is that does apply to lead acid AGM systems. And really some of the main reasons behind that is it's going to eliminate poorly integrated systems, custom systems that are unsafe or underperform. And I've seen pictures of people installing battery-based systems that obviously they didn't know what they were doing, and they'll get a pallet full of parts, and it's not nearly quite so straightforward as putting in a grid-tied system or a grid-dependent inverter, where you just kind of mount on the wall and connect the wires and turn it on, kind of thing. We're getting closer to that, but we're not quite there yet. But we are getting closer to that kind of a turnkey solution. So anyway, it's to help people ensure that they're going to get a system that's safe and they turn it on, it's going to work. Okay, and that UL stamp. So even if you're not in California, having a UL stamp on the entire system should expedite the project permitting as well as the approval when you have your inspection. I have gotten calls from some installers where their local jurisdiction says, hey, you've got like this OutBack pre-wired system, but there's no system UL mark, right? It's each individual device, the inverter, the charge controller, all the different pieces have a UL mark on them, but the system doesn't have one. So then they'll start nitpicking wire sizes and blah, 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 like this. So this should eliminate any of that nitpicking. It should also help expedite any project permitting. You can say, hey, this is UL 9540. So, we've taken these steps to make it easier, especially for those in California. But again, even if you're not in California, there's advantages I just mentioned to having the UL 9540 system. Okay, so Don't want to spend a lot of time on specs and stuff. I just want to do some comparisons here between our Radian inverter and the SkyBox. So the Radian uses charge controllers to do the DC-DC conversion, you know, from the, takes the PV input from the combiner box and uses that for charging the batteries, and also provides the DC input from the PV array to the inverter. With the SkyBox, the charge controller function, that DC to DC converter, is built into into the inverter system, just like a grid-dependent inverter is. It's got the DC to DC converter built into it. With the Radian, these are external devices, but we mount it all onto a single backplate. So this is definitely a two-man lift, I guarantee you. It's pretty heavy, but it is on a single backplate, and you can put a mounting plate on the wall and then just hang it onto the wall and then, and then screw it down. Okay, so in terms of continuous power, we have a 4 kW or kVA and an 8 kVA version. Inside of here, there's 3 modules. There's a control module on the left and then 2 power modules. Each power module is 4 kW. So if there's 1 power module, it's a 4 kW. If there's 2, then it's an 8 kW or kVA. So SkyBox is 5 kVA. In terms of surge rating, we have really good industry-leading surge rating with Radian. It's basically double the continuous power. Whereas with SkyBox, it's a transformerless inverter, right? So there's no magnetic field that can build up and support a surge. So it is limited to its maximum continuous power rating. Time use support, we have like basic time use support. We do have grid use timers, so you can drop the grid up to 3 different times a day, which can be plenty for what you want to do for time of use. But pretty much it's for DC coupling only. SkyBox has some advanced time of use settings where you can put in different rates. It can do like a compare, like does a levelized cost comparison with the battery. So it can decide, the grid is actually cheaper, you know, after midnight. So rather than, you know, powering loads from the battery, I'm going to, you know, power loads from the grid. And then, oh, now that rate has changed, it's actually cheaper to, you know, run off batteries until, you know, the solar day starts. So it's got a lot more sophisticated time of use support, which you might find useful, especially in California. Self-consumption, we can just self-consume like the backup load panel. The SkyBox can self-consume on a whole house basis using external CT. So you put an external CT at the service entrance, so it makes sure that nothing leaves the home. So you can actually export like you were selling to the grid, like you do with Radian. But when it starts to see current flow out, then it just starts reducing its export. So you can, you know, reserve your self-consumption just for the load and not export to the grid. Because a lot of utilities now are, they allow net metering, but they're only giving credit at the wholesale rate, you know, like, you know, sell to you at 15, 20 cents a kilowatt hour and credit you at 3 cents. The location, Radian is an indoor. We do have a NEMA 3R on the SkyBox. But I don't know if I'd leave it in this complete open, maybe, you know, under an eave or, you know, some kind of protection from direct sun and rain, but it does have a NEMA 3R rating on the outside. So in terms of integrated PV, we can convert as much as 6 kW or 12 kW if you have two charge controllers, and up to 300 volts of open circuit voltage. And you can have up to actually 7.5 kW, or I'm sorry, 7 kW of connected PV. So if you want to oversize your arrays a little bit, you can do that up to 7 kW or per charge controller. The SkyBox can convert up to 5 kW of PV, but you can oversize your array up to 6.5 kW nameplate. Off-grid, Outback Radian is a great choice for off-grid. We don't recommend that with SkyBox. SkyBox need to be connected to the grid to do firmware updates, and really it doesn't do surging, which is usually what you want to have for off-grid applications. So we don't recommend it. You couldn't do it. We just find that it's just not the best application for it. AC coupling with frequency watt support. So what that is when we're AC coupled, in other words, when we took, if you want to add storage to a grid-dependent inverter, we insert our inverter between the grid-dependent inverter and the backfeed breaker on the main service panel. So we go in series with the main service panel and the grid-dependent inverter. And so we just pass through. We're basically in that mode. We're just kind of like a piece of copper wire. We just pass that energy through to the main service panel to get self-consumed or exported to the grid. And in the off-grid mode, we become that new grid source. And in that particular case, if the grid-dependent inverter is lightly loaded and has extra energy, that's going to come onto our batteries. If batteries are full and the energy is still coming, then we use this thing called frequency watt, where we increase the frequency. And if it's EL1741SA grid-dependent inverter, it will scale back its output. So it's how we do some kind of rough voltage regulation on the battery, but we do protect the batteries on over voltage and over current, both inverters. So we have very good battery protection for the batteries when we're AC coupled. We can manage up to 7.6 kW grid-dependent inverter. Now with SkyBox, anything above 5 kW is just going to frequency watt that power down to 5 kW. But you can have up to 7.6 connected, but it's never going to convert more than 5 kW. Okay, and yeah, so that's the basic specs. So the SystemEdge packages, so it is a inverter system. Okay, so it's either the Flex Power Radian with its charge controllers, or a SkyBox, a set of batteries, and then we also have this. This is kind of our default rapid shutdown package using IMO Fire Raptors. This IMO switch and power supply and the OutBack relay is good up to 40 Fire Raptors. So if you needed more Fire Raptors, like if you had, like, say, a 4 charge controller system, let's say, then we have another solution for that, which is another seminar. So anyway, this is the basic system that comes with. Also includes our Optics RE monitoring and control system. This is a really, really great tool. If you're not familiar with it, there's no additional charge for Optics RE, but we literally have spent millions of dollars developing this, and it is better than anything else I've seen out there. And yeah, full monitoring control is an excellent troubleshooting tool. So you can look at system performance, you can look at settings, you can change settings, you can look at event history, all back 5 years. So it's really a great tool. And the other thing that's kind of cool about this that we've done is it has downloadable configuration files. So that gets to the the design and sizing. We'll get to the sizing tool shortly, but we know that this combination of this battery with this integrated inverter charge controller system here, we know that it's going to work together. We know that these configuration files that you download are for this particular design. And if you've sized it properly to the loads, which is what the tool that I'm going to show you here shortly, you should be all in. So this whole package comes with a single SKU. And that's what the tool will do. It will help you find that single SKU for the best for the application. And then you just need to order up some panels, and we also have a string sizing tool as part of that. Okay, so these are kind of for the UL 9540. If you choose a simplified battery, we also have AGM battery options also, but if you choose the UL 9540 with the simplified batteries, there's either a 4 battery configuration or a 6 battery configuration, then the SkyBox or the Flex Power Radian. So any combination of these batteries and these inverters are part of that UL 9540 portion of the SystemEdge. Okay, I'm just going to talk a little bit about batteries. Actually, before I get on to the batteries that are part of the SystemEdge, are there any questions so far? Maybe Jamie, you could check the chat box. Have you been monitoring the chat box at all? Or
So far, we're good on the chat box, but I will chime in if anything comes up.
Okay, great.
Thanks, Mark.
Okay, so we have 3 other battery types in addition to the simplified battery as part of our SystemEdge packages. Okay, so these are the ones that come from Outback/EnergyCell. I don't know if all of you know that Outback was purchased by EnergyCell Battery. It's been almost 2 years now. So this lineup here, we have the PLR battery. It's what we call emergency backup battery because it has a long float life, up to 15 years of float. And what that means, if you were to charge the battery and then keep a float charge on it, you could do that for up to 15 years without cycling the battery. And it's really got a nice operating temperature range, -40°C to 65°C. The other thing that's pretty cool about this battery is it cannot be overcharged from the PV array. And you notice the same thing as with the blue. The blue battery is the same thing. And why this is important is, in some cases, we've seen people where they want to go big on their PV array because they want a net meter, self-consume, and they want to go big on solar and small on batteries. And the risk of that is if you discharge your batteries overnight, like say, to avoid some time of use charges, and then you start the morning with a battery that's half empty or less, and you don't control the charging from the array, you could easily overcharge the battery. And the problem in the past has been, so once you set those charge limits, they're there all the time, even once the battery is full. Because once the battery is full, it doesn't matter. The energy will just flow over the battery. There's no longer a danger. Once the battery is full, you don't have to worry about overcharging it. Okay, so with these batteries, you don't have to worry about that. You can go big on solar, smaller on battery, and you're not going to overcharge the battery. Big benefit to these 2 batteries. And the blue batteries also, it's more of a cycling battery. It has a partial state of charge operation. So for off-grid applications, or where it's going to see a lot of partial charging, or if you're doing time of use where you're cycling. Also, you could do some really fast charging. You can charge it really fast. The XLC, that's the big guy in the group here. It's a 1,000 amp hour battery bank. It has 3,800 cycles at 50% depth of discharge. And we sourced this battery from Hitachi. This battery was used when they had that Fukushima nuclear power disaster after the tsunami. They put, I don't know, a couple hundred of these batteries together to make this really huge battery bank. And it can do 3,800 cycles at 50% depth of discharge, which is approaching lithium ion performance. And it's got a 17-year standby life, which most people are not going to keep them in standby for that long. That's more for telecom applications. UPS applications, but it has a 10-year replacement warranty, which is somewhat unheard of. So, and that is conditional, though, on you having a monitoring system like Optics RE in place. So if you buy an Outback system, of course, you're going to have Optics RE, so it's not a problem. But that's just kind of the general introduction on these batteries. This is a spec sheet. We're going to make this presentation available so you can go through this. I'm not going to go through every single specification on this there, but you can see they're all very highly efficient batteries in terms of round trip efficiency, in terms of like losses and whatnot. Operating temperature, you notice over here on the Simplify, it's -0C to 49C. Not a huge, there is a wider temperature range for discharging, but not for charging. So since you're going to be charging your batteries, not just discharging them in the same environment, I put the charge temperature range on here because really it's the limiting factor. So keep in mind that, you know, especially in California or other places in the South or in Texas and places like that, you'll want to make sure that you have some level of temperature control so that it doesn't get too out of hand. Cycles at 50% depth of discharge. You know, the blue has more. It's not a huge amount more than the PLR, but definitely some. Cycles at 80%. So with the blue battery, we really, it's a partial state of charge battery. So between 50 and 90%, it does great, and you can actually extend cycles in that range. But when you get below 80%, we don't recommend this battery for that. However, with the PLR, you know, at 80%, you get 800 cycles, so you get quite a bit fewer cycles. But hey, if you have an emergency backup application, you have your battery-based system, mostly you just want to net meter, self-consume your solar, and, you know, hey, if you lose power 1 or 2 weeks out of the year, like you're in one of those public safety power shutdown areas in California, and you know, like 1 or 2 weeks out of the year, you're going to be shut down. This is plenty of cycle. You know, if you cycle your batteries once a day, 14 days a year, it's still beyond the flow life of the battery, so no big deal. But you'll notice that on the XLC, when you get down to 80%, you lose a lot of cycles. So with the XLC, you probably don't want to discharge below 50% also. And then the Simplified has a lot of cycles at 50%. Okay, so in terms of float applications, this is really a great battery, the PLR battery. We don't recommend it for cycling. XLC and the Simplify are best for cycling applications. The blue is just kind of a good all-around battery. It's like the least expensive of all of them. Warranties, 3-year, 10-year on the Simplify. I think for the Simplify battery, though, you need to have like a maximum 80% discharge. So you never use up more than 80% of the battery in order to get this higher cycle life. Okay, so levelized cost of energy for a 20 kW system. So using some prices I got on the internet, although I found that I think this XLC price is even less than what I used. So using this depth of discharge for battery capacity, this is kind of like a levelized cost in terms of cents per kilowatt hour per cycle. And you can see that the XLC is really a very good battery, but it's also pretty expensive. And the Simplifies, if you look at the Simplify in terms of just like kilowatt hours per cents per kilowatt, or there's some ways to make that number look really good. But when you get enough batteries to do a 20 kWh system, then, you know, the price goes up quite a bit because that's a lot of batteries. And so anyway, this is just kind of a relative, give you sort of a cost. Like the blues are a lot, in terms of kilowatt hour per cycle, but they're the least expensive. And if people don't have the money, they don't have the money. And maybe somebody doesn't have $20,000 to get an XLC battery or a simplified battery system. So anyway, any questions on this?
Yeah, one thing I want to chime in, we got a question that said, to achieve the UL 9540 requirement, does the energy storage have to be a lithium chemistry? And if that's true, wouldn't AGM be ruled out?
Yeah, so this is really kind of it's a really good question that you asked. I'll try and clarify it as best I can. UL 9540 only applies to lithium batteries, okay? And I don't believe that even in California that they will restrict you from using, an AGM battery in a system. And a lot of the jurisdictions, they're not even enforcing, they're not even aware of UL 9540, even though it came out 2 years ago. It takes a while to get that out there. So to answer your question, if you're going to use lithium batteries, then yes, it definitely has to be UL 9540. If you're not using lithium batteries, then no, it doesn't. That's my understanding. That's Outback's understanding of how that works. So it's not saying you have to use lithium ion batteries, but I would check with your local jurisdiction and find out what their interpretation is, because that's all that matters. They are kings of their own fiefdoms there, and I would check with them. But it's my understanding. I mean, the batteries are listed UL 1973. And you're using it with the UL 1741 inverter, there shouldn't be a problem. It just, we didn't do the testing to UL 9540. And again, there's going to be another standard, because I think they kind of UL kind of realized that, hey, yes, there are lead acid AGM batteries that people are using, and we're not saying no, you can't use those anymore. So I think if you look at the intent behind it, was not to say, okay, you have to use lithium ion batteries, quit using AGM batteries. That's our interpretation of it. But I would talk to your local jurisdiction and see what they say. It's been my experience talking with installers that when they come out and look at the DC side of the system, they really don't know what they're looking at most of the time anyway, and they're just checking wire sizes and breakers, and wire sizes match up the breakers and all that. So.
Great. Thank you, Mark. That makes a lot of sense.
Yeah.
And another question, and this is sort of as it relates to the levelized cost of energy. Do you have information regarding the capacity degradation over cycle life as that pertains to kind of the overall performance of the batteries?
Yeah, the deeper you discharge, the fewer cycles. The other factor, really important factor in the battery life, is temperature, right? So when you are charging and discharging a battery at high temperatures, that definitely has an impact on the battery. Probably as much or nearly as much as the depth of discharge. So temperature, if you can keep the batteries like in a place it's going to be, maybe not air conditioned, but I've even seen people, put, like some kind of air conditioning, but you set the thermostat up really high, like 85, 90 degrees or something, just so it doesn't get too hot in there. And because it depends on the batteries. You can look at the operating temperature. Some of these batteries do better in higher temperatures. Like you look at the blue battery and the XLC battery, both have operating temperatures to 65C. Now they're still, even those batteries, even though they're spec'd at that temperature, just lead acid, the way it works is that you do get more degradation charging and discharging at higher temperatures.
Thank you.
Anything else?
I briefly answered this on the chat, but can you tell a little bit about the safety components of an AGM, like lead acid batteries, as opposed to lithium ferrophosphate? Because it was kind of my understanding that people find the lithium ferrophosphate safer than, say, a nickel manganese cobalt, particularly as it refers to thermal runaway. But is thermal runaway something you have to really consider for lead acid batteries as much?
Yeah, I'd say, I'm probably not qualified to answer that question, so I'm gonna answer the question very carefully.
Sure.
Yeah, in general, there are specifications, and you can do some internet research. I think there's this like battery university or something like that that has some really good information on this, and you can look at the specification. There's of the different lithium ion chemistries, and some of them have higher and lower thresholds with regards to thermal runaway. But even lead acid batteries do have a threshold for thermal runaway. If you overcharge them long enough in a hot enough environment, you can get thermal runaway on a lead acid battery. It's not very common, but it can happen, especially with AGM batteries. I don't think it happens very often. And I think where a lot of battery fires have started with lead acid batteries is the flooded batteries, because they off gas hydrogen, and which is much more volatile. So yes, I'd say in general, AGM batteries have a lower threshold of thermal runaway than lithium ion batteries. But even within the lithium ion battery category, yeah, I think the lithium iron phosphate are the ones that have the best, thermal runaway rating on them. And lithium ion cobalt, I think that's what Tesla uses in their batteries. But to Tesla's credit, I mean, because those batteries that Tesla uses, they have the best power to weight ratio. So for mobile applications like electric vehicles, that makes a really good battery because it has such good power to weight ratio to it. But it's also the most volatile chemistry. But to their credit, they do, even with all those cells, they monitor each cell. They have active cooling. Um, if there's any kind of like as cells start to deteriorate or go bad, then they'll adjust the charging voltage, and so they really have a pretty sophisticated BMS. Some of the lithium iron phosphate batteries I've seen don't really have some people refer to kind of a dumb BMS. It doesn't interact with anything outside their system. It just kind of looks on itself, and they're designed to operate like an AGM battery.
Sure.
So I don't know if that kind of a long answer to the question.
No, that's very helpful. And then Mark, can we get a sneak peek, a little bit of a demo of this sizing tool?
Absolutely. It's funny you should ask, because I believe, that's
Yay!
the next that's
Phenomenal.
the next slide. So here is the URL for this, but I'm just going to show you. Let me switch over to hopefully I can bring this up. Okay, so let me bring this over to the active window. Can you see the OutBack website now?
Looks great, yes.
Okay. Okay, so on the OutBack website, you select the installer section, and you come to this point here, and then you go down to resources. And then under resources, over here on the left-hand side, there's the SystemEdge Sizing Tool. Now you notice below that is a string sizing tool. So this is like a tool I developed that's just for string sizing for the charge controllers, the FM60, 80, 100, and SkyBox, right? So, and it's just for string sizing. The SystemEdge tool is, it has a string sizing component in it, but it's more for choosing the best SystemEdge package for the application. So again, you just go to Outback, Installer, and then click under Resources, and you'll find the SystemEdge Sizing Tool. So we'll just go ahead and bring this guy up. Okay, so the first thing we run into is choose an application. So we have emergency backup, and also if you want to know what these are, there's a definition up here, but I'll just kind of explain this a little bit. Energy management is like if you're doing time of use or self-consumption, where you're going to be doing more cycling of the battery. That is one application area. And it's very similar to off-grid, actually, because off-grid's also a cycling application. But the difference is if you choose off-grid, then we're going to eliminate SkyBox from the selection because it's really not that good of a, we don't recommend it for off-grid applications. So that's going to be the main difference when you select energy management or off-grid. We're not going to have, the SkyBox systems are not going to be an option. Then when we go to emergency backup, that is going to replace the blue batteries, which are more of a cycling battery, with the PLR battery. Okay, so depending on how you pick the application, we are going to remove or replace certain inverters or certain batteries. Okay, so we make sure that you wind up with the best inverter battery combination for the application. Okay, does that make sense? Okay, choose a power type. We were at one point going to have our 120 volt FP1 was going to be a SystemEdge package. It no longer is. And then we thought, well, maybe someday we'll do 3-phase, blah, blah. So anyway, there's no selection here. We just left it in there for future products. Okay, so the first thing, second thing, I guess, after choosing an application is to develop the load profile. And this is so important. One of the things that a lot of times I'll ask an installer, especially if it's a problem site, is if they did a load profile, and they'll just, no, it's, because they think, oh, I have to go out there and put on some load monitoring equipment, and or they don't really know what loads they have or whatever. So we preload this with 5 like common load types, and you can change the parameters. You can change the quantity. Okay, like light bulbs that say, okay, like I actually have 10 lights, not 5, and they're actually they're actually 20 watts, whatever. And we use them for 5 hours or 6 hours a day, not 4. And, we're never here on the weekends, so 5 days. So you can do all this. And then we have something called a surge multiplier. So if it's a surge load, we add a little bit of extra. So on the surge capability. And then down here, you can see we have total power. So that's if all these loads, that's when we have the quantity times the watts, and we don't show the number, but collectively, when you add all the quantity and watts together, that's if we had all these loads turned on at the same time, how much continuous power would we need from the inverter, okay? Then when we add a surge multiplier here, that's this number times this number here, that gives us a surge, and then we use the surge rating from the inverter to know, hey, if we're going to be able to handle surges okay. And then the hours per day and days per week gives us the kWh, right? So this is what we use to size the batteries. So these two numbers here are what we use to size the inverter. This is what we use to size the batteries. Hope that makes sense. Now let's say you wanted to change a load. Like let's say I don't have a laptop, but well, let's just search for a load. Let's search for hair dryer. Somebody in the house uses a hair dryer a lot. You have like 4 daughters and a wife or something that uses a lot of this. So you could go up to hours per day. That's a lot of work with the hair dryer. But you can notice that power went up quite a bit, and it's not a surge load, but just the kWh of adding a 1500 watt load for 4 hours a day really bumps it up. So maybe, hair dryers is low, but maybe there's some other load, could be like a space heater. A space heater has a very similar load requirement to a hair dryer, right? And but let's go back and put laptop back in here. And we could also, so we can do that search. I can add a row. So if I want to add something, and I want to choose the appliance, I can either do a search, or I've got this this drop-down menu. Can you see that okay? Does it show up?
Yeah, it's still visible. Yeah.
Okay. And actually what I should do, maybe I'll show it up here. So it'll be a little bit easier up here.
Great.
So there's a drop-down menu. You can choose certain things. But you'll want to check, like every UL device should have a voltage and a current or a VA rating or a watts or something that you can use.
Yeah, this is a really good point. Is the best way to find that out going to like the Underwriter Labs page? Because like when I've prepared for some of these types of webinars, like I often go to the manufacturer's website, but the manufacturer's information is sometimes lacking or kind of spotty. Like, what's the best way to get a true wattage or a true volt and amperage value?
It should either be a sticker, or sometimes it's even embossed into the plastic molding of the device, because UL does require that information. So you should be able to get it from the device. Sometimes it's not convenient, or sometimes it's worn off, the label's fallen off, and then you could do like you say, or this isn't rocket science. As long as we get close, you should be okay. Sure. So we have a central air conditioner. Look and see what that did for our total surge and total power. So I'm going to hit the calculate button right now. And let's see what it gave us. So it says, save your requirements and please contact the sales team at Outback Power, right? So what we've done is we've actually exceeded the surge rating, right? So the Radian has a maximum surge rating of 20.3. So let's, and here's, okay, I'm going to go ahead and get rid of this just to show you how to get rid of a row. I haven't shown you that. So we're not using this right now. So we just mark it and then hit delete row to get rid of it. So
can you show us how you'd put in like a custom wattage value?
Okay, sure. I'll do that right now. I was just gonna do the central air conditioner. Let's say that we tell the customer, say, look, we don't even have a system that's really gonna do it. You look at the size of the battery bank you're gonna need. So what if we go to a mini split, a 1500 watt mini split? So okay, there I changed the power like you requested. And look what that did. Our surge went down from 20 kVA to 9.8. Now we could even use a 4 kW Radian. The energy required to power it. And a lot of people don't realize how much power the air conditioning consumes. And, and this is really going to reduce the size of the battery bank, the size of the inverter, and this is sort of the trade-offs that you can talk to with the customer, and you can do this in real time with them. You could even do this remotely. You could do like we're doing now, do a Zoom screen share with your customer and say, they say, yeah, I got to have air conditioning. And then they see what the price difference is. They go, oh, yeah, maybe a cooling room makes sense. We'll do a mini split instead. you know, it's only a week or two out of the year. It's okay. We can live with that. So let's take a look at. Okay, we have to recalculate, and let's see what we have. Now we have some options to choose from, and we are on energy management. And so we have this, the AKW Radians, and then we have some different storage options here. So the minimum would be with the blue batteries, or we could do 6 simplified batteries, or we could do the big XLC. If they say, yeah, I just want to have make sure I have enough power. So 29 kWh. The other thing that we do, you notice this wording up here, we say effective storage. So for our AGM batteries, we take 50% of the nameplate because we presume you're not going to want to discharge more than 50%. On the simplifies, we do use 80% of the nameplate. Because we presume you want to have the maximum warranty. All right. Also, when I switch over to emergency backup and then recalculate, you'll notice that the PLR batteries replaced the blue batteries. Okay.
I actually have a question about this. So is there a way to incorporate, like, maybe this is wishful thinking, but both energy management and backup, meaning like maybe I want to do self-consumption most of the time, but then if a storm is coming, then I can kind of gear up and be in emergency mode also?
Oh, sure. That you can always do that. We're just saying, what's the best battery for the application?
Okay.
Yeah, the inverter can do, yeah, I mean, that's the heart and soul of our inverters, provide emergency backup, and they all do that. So every application will do that. It's just how often are you going to need emergency backup, right? Sure. And so that's kind of, if you just want it for emergency backup, then the PLR battery is a really great battery. It's the most cost-effective battery. It lasts a long time. It's got high temperature ratings. It's just really great for this application.
Awesome.
And but if you're going to be cycling, like, you know, emergency backup, or let's take a look at off-grid. Let's go back to emergency backup. So one thing you can do you can say, okay, how do we get this surge down? I really want to use the SkyBox, okay? And the total power is below 5 kW. So what am I going to do? So you can say, well, you know, I'm going to put a soft start on my air conditioner. Okay, and so I'm going to take this down. I'm going to get rid of the surge because I'm going to use a soft start. Well, that's still not going to do it, right? So maybe maybe I'm not going to use a microwave oven, or I'll make sure I get a microwave that doesn't surge, right? And so you can kind of, you know, game the system a little bit, or remove some device that you don't want on there. But now that I'm below the 5 kW limit on the surge, and I hit the calculate button, you'll notice that my SkyBox options are now here, right? And they're the 5 kW ones. So you can just look and see. I mean, it's in here also. It's a SkyBox. It's
when we look at the days per week, can you talk about how that impacts autonomy, like days of autonomy?
Yeah. So what we do is we assume that we assume a 24-hour autonomy. Okay.
Great.
So the days per week, like normally you talk in terms of days of time. That's a really good question you asked, by the way, and very good question. We size our systems for 24-hour autonomy because, you know, that's going to handle, like, you know, probably 60-70% of the time out of the year. So if you say, well, I want 2 days of autonomy, well, how many times how much more coverage you're going to get by going 2 days of autonomy? Maybe 15% more days, 20% more days. So the biggest expensive part of the system is the batteries. So if you want that second day of autonomy, now you're going to have to double the size of your battery bank, right? So you've just doubled the most expensive part of your system. Now, getting back to your question on days per week. So days per week gets into total hours, right? And so we take those hours and we convert them to kilowatt hours. It doesn't really affect days of autonomy. What it affects is the kWh, right? Because we take days times hours, or hours per day times that to give us hours, and then we take the hours times the watts to give us watt hours. So there could be some times when, you know, if you've got a load that's only on like 5 days a week, when we do the math, it will reduce the kilowatt hours, especially, you know, microwave or whatever it is that you know, washing machine or something you only use a couple days a week. It will reduce the size of your battery bank.
Great.
Okay. All right. So, and then you can see when we switch over to off-grid and we recalculate, even though we're below the 5 kW rating for SkyBox, it's still not an option because we don't recommend it for off-grid. So it's really important that you pay attention to the application. And again, if you're not sure, up here describes the application, and you know, you can add as many as you want. You can change it if your ceiling fan or laptop or whatever has different power ratings. You can, or you different hours per week. We just kind of pre-populated it to kind of get people started. Okay, so now we need to select an option. So let's go with the Flex Power Radian and the let's go with simplified batteries and say, okay, so now we have to do the solar. So we can adjust the ambient, you know, temperature, which is going to affect, you know, your VOC and VMP calculations, which are hidden from you. You don't have to worry about those. We'll take care of it. So you can adjust these high and low temperatures for the site location. We have a drop-down menu of over 200 different, you know, types. Let's just pick a Canadian Solar 340, and we populate with all the information that we need for our calculations. And then we hit the little calculate button, and we have the maximization. So you can change this around if you want to. And the maximization just does this to say, okay, we can have up to 7,000 connected watts with a Flex Power Radian, because that's what the FM100 charge controller is rated for. But you might not want to do that configuration. You might want to do, let's say, you want to do 6 in series, and that gives you this number of strings. Now it gives you power, but you say, okay, I'd rather do 6 in series, fewer strings, and you know, this is plenty for me. And so it says, okay, that will take 18 total Canadian Solar 340s. Now keep in mind, the system that we selected up here has, it's an 8 kW Flex Power Radian that has 2 charge controllers. So you'll need to double this quantity. So that'll be, you know, 36 of those. Then we click on print result.
I want to say, Mark, I'm really pleased that the order of this tool starts with, really the first thing you're really inputting is the load calculation, because that is how sizing these systems or thinking about storage in general should start. I know a lot of people often think, let's think about the PV first. But in a battery-based circumstance, we really do want to start with the loads Then we look at our inverter and battery option based on those loads, and then pair the PV last. So I just want to applaud the kind of sequence of this, because it's really how you should be considering thinking about these systems.
Well, thank you. I appreciate that. I mean, put some thought. There's one little thing on here, at least with the Chrome browser anyway, it doesn't put the header for when the first time you bring this up, it doesn't put the header. If I hit cancel, I hit print result again, then it puts the header up here. I don't know why, but it does. So anyway, this has all the load calculations here, the total power, continuous power, surge, kWh, which is used for sizing the battery. This is the system that you selected. Here's the SKU for that system. Here's the ambient temperatures that were used on the string sizing. We used the Canadian Solar 340, and then these are all the specifications that we used. And here's the configuration. So what's really nice about this is that you have a configuration that you can send to Soligent, and they say, okay, hey, here's what I need, and other than a few additional some additional pipe and wire and whatnot, you really you have all the rapid shutdown stuff you need as part of the package as well. You just need some pipe and wire, and you're pretty much good to go. Download the configuration file, load it into the system. Now, the configuration file doesn't cover things like if you're having a generator, you'll have to do that advanced generator start programming. But in terms of like battery programming and that, it really is like 90% there or more. But anyway, this is kind of a way to kind of protect yourself, because I've heard from many installer that said, hey, they didn't tell me about the pool pump or whatever load that they had. And here you can go back and say, look, Mr. or Mrs. Customer, this is what you told me that you wanted backed up. This is, the system, how the system was sized. The batteries should provide 24 hours of backup. The system should just, keep going every 24 hours. It should recharge the batteries. And, so this is a really good way to not only, specify a system, but sort of a way to cover yourself should the customer come back and say, hey, the system's not performing. And this will take care of the what I call Mark's 90% rule of design, configuration, and sizing issues that a lot of people run into. So, I just want to do one more thing. On the, there's always new solar modules coming out. So you can put in a custom, so you can say input custom data. So you can put in the module name, power, all the appropriate specs off a data sheet. So if you do have something that's not on that drop-down list, you can put input custom data and then calculate based on that.
Awesome. I just want to have one more question that someone had mentioned, which is a good one for your expertise, Mark. How do you typically evaluate surge? I think with motors, it's kind of more apparent because you have the fixed, the locked, and then the surge amps with the rotor. But how do you consider like the microwave, let's say?
Yeah, microwave is an interesting thing. That there's just going to be surge with microwave. I don't know how you're going to. I don't think a soft start is going to work with a microwave. At least I've never heard of it, and I don't see manufacturers that spec it. But with motors, for sure, and a lot of people get locked rotor confused with inrush current. And I think the best way to illustrate that is one application I ran into was at some big automotive manufacturing plant. They had this retention pond that collected all the runoff from the parking lot. It was a monster parking lot, like 2 football fields. And and they decided to go green on their on their pump. So they had like a 3 horsepower pump, and they looked at the running current was, I think, 11 amps, and the locked rotor was rated for like 17 amps. And so when I got there on site and I was looking at it, it was just, the inverter just wasn't able to handle that surge on it. So later on, I took a picture of the nameplate, and it was a Baldor motor they had, and I went to the Baldor motor website, and they had a separate spec for inrush. So while the running current was 11 amps and the locked rotor was 17, the inrush current was 87 amps. Okay, so there was no way. I said, look, even before I found that out, I said, look, I can tell just by the way this thing's struggling to start. I worked with motors a lot. I said, you're going to need to put a variable frequency drive or a soft start on this motor, and which they did ultimately. But getting back to, like if you were to look at the surge factor, and ever since they came out with high efficiency motors at the turn of the millennium, they actually have more surge current because what's called the slip between the magnetic field and the current is much tighter and makes them more efficient, but they also has actually higher inrush current to them. And really a soft start is the best way to go if you want to minimize that. I think it's the most cost-effective way to do it and most reliable. A variable frequency drive, you can do the same thing. But in terms of the sizing, if you were to size just for that, 100 milliseconds of inrush current, you'd have an inverter system that was just like way too big. And so we found that by using a factor of 3 instead of, the actual inrush current might be more like a factor of 7. You're probably going to be okay, just because you have all these other you're sizing for all these other loads in the system. But to be sure, on our inverters, I don't know about the SkyBox because they have surge, but the Radian it has a 100 millisecond spec, which is like 5 cycles, and that's really, I've done tons of measurements on inrush current, and that inrush only lasts about 5 cycles. So if you look at the 100 millisecond spec on our Radian inverter, I think it's like 67 amps. So even one Radian would have been enough to handle the inrush. Right. But I guess what I'm saying is, as long as we can handle that inrush, and you have multiple devices that have inrush, I wouldn't worry about too much, because the chances of them all coming on at the same time are unlikely. But do look up that 100 millisecond spec, and also go to the motor manufacturer site, because locked rotor is not the same as inrush. It can be. It's kind of like with batteries. I found what some people call absorbed, some people call bulk, and blah, blah, blah. So make sure that locked rotor is actually what that motor manufacturer is calling inrush. Great. So I know that's a really long-winded explanation, but I don't know how else to shorten that
no,
call.
That was great.
But I think if you use the 3 inrush factor, you should be okay. I've been using that for a long time, and I haven't run into trouble yet.
Great. Well, thank you, Mark, for these detailed answers, because I think this is really what people want to know about how this is affecting real life sizing. So there have been a couple more questions, but we've gone a little bit over in time, so we will answer those offline, and we will get Outback and Soligent in touch with any additional questions. Thank you so much, Mark. I really, really appreciate it. So everyone, you can go to this website per the URL and have fun on this tool, and let us know your feedback on it.